So this video is about logarithms and just an introduction to what are log functions. So that's the first question here. So what is a logarithmic function? So it will look like, f of x is equal to log of x. Okay, when I'm dealing with this parent function, the base on this function that I'm talking about is base 10. So if I leave out the base, it's assumed to be base 10 because that's actually what calculators deal with is base 10. So if we're going to plot this graph and see what it looks like, I can make a little table of values and using a calculator to help me out. If I choose different values of x and trying to figure out what the corresponding f of x will be or the y value will be. So let's start with 3. So if x is 3 and I plug that in here into the parent function for x, so using a calculator, depending on how your calculator works, you might have to press 3 and then the log button, or you might press log and then 3. So I get 0.4771. I've rounded it a little bit there. Now let's choose when x equals 2 and plug that in. What do I get? I get 0.3010, so I see that it's decreasing when x is 1. If I plug that in and press log, I get that y is 0. When x is negative, oops, I missed 0. When x is 0, if I plug that into the calculator, what I get is an error. And then if I continue and go negative, I keep getting errors. Okay, so it looks like here I have a problem. My function will never reach y equals 0, so I'm going to have an asymptote on the y-axis. Or sorry, I can never reach x equals 0. That's what I meant, sorry. So then I'll have an asymptote at the line x equals 0. And then I can plot those points to kind of see what happens. So I have an intercept at 1, 0. And then I have 2 and then a little bit, and then 3 and then a little bit more. And then it's actually going to take on this shape. So as I get closer and closer to 0, so I didn't choose any numbers between 1 and 0, but I could have chosen like, a quarter or a half and things like that, and I would see that I'd be approaching that y-axis but never reaching it, and then it's going to take that shape there. So it looks like an exponential function. I'll draw it a little bit better. It looks almost like an exponential function, but just kind of flipped. So logarithms and exponential functions are actually inverse functions of one another. Okay, so we do have some rules that go along with logarithms, just like we did with exponents, and let's see what those are. Okay, so I have some different things here. So I can split up my logs if I have the same base, and they work either way. So I can, if I am multiplying two things together with the same base, I can split them up and I can add them together like this. Or if I'm adding two things with the same base, I can bring them together and put them as one logarithm and just multiply together. So let's see, if I had the log base 3 of 7 times 5, that would be the same thing as log base 3 of 7 plus log base 3 of 5. Okay, so as long as I have the same base, I can bring them together, just like with exponents, as long as I have the same base. Okay, if I have log base 5 of x over 10, if I'm dividing, I can split that up in here and subtract. So again, I'll have log base 5 of x, the numerator has to come first, minus log base 5 of 10. Okay, and then another rule, the exponent rule. So if I have log base b to some, or log base b of m to some exponent, I can actually bring that exponent down in front and multiply by it. So if I have, for the example here, log base 12 5 squared, I can bring that 2 down in front of the log. So I'll have 2 log base 12 of 5. And then another really useful rule here is that if I have log base b of b, so the same thing, so like log base 2 of 2, or whatever it is, it's actually equal to 1. So log base 5 of 5 would be equal to 1. So this is a really nice little rule to help you simplify some logarithms. And then as we saw on the graph, we had an x-intercept of 1, 0, so log base b of 1 is going to be 0, so that's another nice one as well. Okay, so let's see some more examples, or more rules as well. Okay, so I can change from log form to exponential form, going between, so I can go between the two. So if you look to see the relationship between them, so my base is the same in both, I keep the same base. Then when I'm going from log form to exponential, I take the answer here, the y, and that becomes my exponent, and then my m is what it's equal to, okay? So for example, just to show that this is actually equivalent, that log base 3 of 729 is equal to 6. So 729 is the same as 3 to the 6, so I'll rewrite it like that. So log, right, so I have 3, my base is 3, to my answer, 6 is equal to 729. So they are the same thing. I could have also simplified my logarithm side if I wanted to, using some of my log rules. So let's see that way. So I know that 729 is 3 to the 6, so let's replace that with 3 to the 6 equals 6. So I remember I had that exponent rule where I can bring that exponent down in front, so I'd have 6 log base 3 of 3 is equal to 6, and yes, because log base 3 of 3 would just be equal to 1, so you'd have 6 times 1, which equals 6. Okay, and one last quick rule. So you can use this change of base formula as well. So what it does is if you're given some base b here and you want to change it to this base d, you can use this formula. So on the top it's going to be log your new base of whatever this value was over log your same new base again of whatever your old base was. And so why do we need this? Well, your calculator will only deal with base 10. So you can't, unless you can simplify it using some of those, using some of those rules or something like that, or use a computer program, your calculator, basic calculators will only do log base 10. So it's useful to change into log, just regular log base 10. So if I want to change this example here into base 10, I'll have log, and I'm choosing, I can choose any base I want, log base 10 of x, which is 5, over log base 10 of the old base 2. Okay, and then you could use your calculator and you can calculate, well, the log of 5 is something like 0.69897 over the log of 2, which is 0.301029, whatever, and then you can just divide those two numbers. Okay, that's it. Thanks for watching. Good luck with the assignments.